Well, folks, so this is the fourth problem of mock test paper pertaining to fluid mechanics. In this problem, actually it is saying a hollow cylinder is held submerged in water with top surface at water surface. That means, suppose this is the cylinder, we are holding it, we are applying some force and we are keeping the cylinder just submerged so that the top surface of the cylinder is at the water surface. Now, this is now released, and if it is allowed to ascend gradually, then of course it will have, in this condition, it will start floating. So we have to find out what is the work done by the buoyant force on the cylinder if it is allowed to ascend. Well, with this picture, we can find out H dash rho water into G is nothing but rho of cylinder into H into G, or H dash upon H is nothing but rho C upon rho W. In this question, actually some data is given. Is 50 centimeter square, then H is your 60 centimeter and rho C upon rho W is given as 0.5. So we have to find out the work done. So work done, we already know, F into dx. Suppose if we take a small strip of water, then this will be nothing but rho W into G A Y into dy. If we integrate, this H is going to change to H dash. So this is the work done by the buoyant force. Now let us integrate it. G A, this is y square y square as well. This will become h dash square upon 2 minus h square upon 2. H square, if we take outside, C, A, even 2 also, if we take outside, then this will become h dash square upon h square minus 1. This we know, this also we know, this no, this we know, this we know, like that. If we can calculate this and this answer, we can find out. Answer will come as it will come as 6.615 joule. So this was the fourth problem. Now we will go to the fifth problem. So this is the fifth problem. We have to find out the inner dia of the hollow sphere, and it is almost submerged in water. So it is in this position, means it will displace the equal amount of water equivalent to its volume. So if this, suppose weight of the hollow cylinder is mg, then it must be equal to rho water into g into volume of the sphere. This is nothing but volume of the iron into rho I into G so this is nothing but your this is okay, this is nothing but it is given as rho I into Vi will be nothing but 4 by 3 pi minus 4 by 3 R pi into G will be into G into, and this will be nothing but 4 by 3 pi R, because the water volume of the water will be equal to the outer volume of this sphere, because same amount of water it is displacing. So we know R, we know R0, We know this also, G also. So we can find out this thing, and we have to find out the R. Suppose then you simplify, then you can get it as 76.3 centimeter. Now we'll go to the next problem. So this is the sixth question. In this question, it is given a pump is throwing water at velocity 4 meter per second through a pipe of radius 1.2 centimeter at a height of 2.5 meter. Find the power of the pump. So this is the hose pipe. It is 1.2 centimeter radius is there, height is 2.5 meter, and velocity is the water from this sump is coming up 4 meter per second. So let us see what is the mass. What is the mass of the water is being delivered per unit time? Suppose delta M is the mass water being delivered in delta, suppose T. Now this mass delta M, it will have mgh, delta mgh, it will have this much potential energy because it is being raised from here to here, and at this point it will have velocity also, so it will have kinetic energy also. So this is the potential plus kinetic energy. This is the total energy it is having at this point, and it is nothing but this is the work done. By the pump. Now, work done by the pump in delta T correct? And this is nothing but power of the pump. This is what we have to require. Now, what is delta M by delta T? Rho into area of the hose pipe into velocity, because this is velocity is nothing but 4 meter per second. In per unit second, it is delivering 4 meter of water. So it will have in 1 second the mass will be this rho into A into V. This is the Ma- mass per unit time is being delivered by the pipe. So P we can write it as rho A V into plus half. Any problem? We know rho, it is water. We know area because a radius is given. We know velocity, it is given 4 meter per second square. H we are given as 2.5 meter. So by putting all these values, we can find out answer as 58.7 watt. So this is the sixth problem. Now we will go to the seventh problem. So folks, this is the seventh question. In this question, a pitot tube on a high altitude aircraft measures a differential pressure of 160 PA. What is the speed of the aircraft if air density is this much? Basically, pitot tube is used to measure the speed of the aircraft. This is basically the pitot tube. And this, here at point B, all around holes are there. And this is point A. Now, when aircraft is moving like this, air will flow like this, and at this point, the airflow will stagnate. But at this point, of course, there will be airflow. And whatever is the velocity of airflow, if you measure here, it is found that it is almost equal to the aircraft speed. Now, one more thing. At this point, air is stagnated, and here, so velocity is there, so there will be a drop in pressure. And due to this, it is attached with a U2 manometer, and there will be a differential level because of difference in pressure here. You will find the difference in level here. So, in this case, PA will be nothing but PB plus half rho V square. It is due to the Bernoulli's theorem. Now, we know PA minus PB will be nothing but here whatever the difference in pressure is given due to the differences level. So this delta P will be nothing but half rho air V square, or V we can find out as 2 delta P upon rho air. So this is a very simple question. Rho air is given here and delta P is also 160 PA. So, but what is pitot tube? I wanted to give some idea about this. That's why I have chosen this problem for you. So this will be nothing but 103.3 meter per second. The speed of the aircraft. So I hope you understood this problem. What is pitot tube? This is you can have this some idea about this. So now from problem number 8 to 11 you will find in my next video. So we will go to the next video.